Dear students, welcome to this channel. I am AGRAJ RAGHAV from Vidyarashmi 09. In this video, we will learn Class 9 Mathematics first chapter number system. In our daily life, we are using numbers. Sometimes we have to naming or representing a number in a number line. The system of naming or representing a number is known as number system. We know several types of numbers. I will just recall that. First one, natural number, a collection of number which start from 1 and continues like 2, 3 and 4 so on. Such collection of numbers is known as natural numbers and it is denoted by the capital letter N. The natural number contains 50, 100, 200, all those elements. And if we include 0 to the natural number collection, then that collection becomes the collection of whole numbers. Here you can see, including the natural number, one more 0 is added to the whole number collection and it is denoted by the symbol W. Next one, if we include negative of the natural number like minus 50, minus 100, minus 3, minus 2 to the whole number collection, then the huge collection become the collection of integers. Written here the collection of integers. For example, minus 10, minus 100, 200, 0 are the elements of the integers and it is denoted by the symbol capital letter Z. The next type is rational number. You may come across this. For example, I will give one situation while getting the answer sheet after valuation. If you score 90 out of 100, your marks is like this. It indicates 90 out of 100. Out of 100 marks, your score is 90. Okay. So, you can see a number which is in the form of P divided by Q, where P is 90, Q is 100. Such kind of collection of number is rational number. I can define the rational number as a number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is very important. Q should not equal to 0. And for example, 1 by 2, minus 11 by 8, so on. And you may get a relation between natural number, whole number, integer and rational number. Like every natural number is a whole number, right? Every natural number which belongs to the collection of whole number. But not every whole number is a natural number, because there exists 0 which is in the collection of whole number but which is not in the collection of natural number. Same way, I can tell every whole number is an integer but not every element in the integer is a whole number. Same way, every natural number is an integer but not every integer is a natural number. And this is very simple, right? But I can prove every natural number or every whole number or every integer is a rational number, but not every rational number is a natural number, neither natural number nor whole number nor integer. How? Let us take one integer. It is enough if you take one integer, because integer contain whole number and natural number. Okay, so I am taking one integer minus 8. Okay, I have to write minus 8 in the form of P by Q. Yes, I can write this as P by Q just by writing the denominator value as 1. Any number can divide it by 1. So minus 8 also can divide by 1. I will write minus 8 in the form of minus 8 divided by 1. So you can see this is in the form of P by Q, where P is equal to minus 8 and Q is equal to 1. So every integer can be written in the form of P by Q. That is nothing but every integer is a rational number. The next concept is decimal expression of a rational number. As we see here, 1 by 2 can be written as 0.5. How? Just a normal division, right? 1 divided by 2, 1 cannot be divided by 2, so you have to take 0.5, it becomes 10. So 2 5s are 10, then the remainder is 0. That same way I can tell 5 by 10 as 0.5 and 100 by 200 is also 0.5. You can observe here 1 by 2, the value of 1 by 2 which is equal to the value of 5 by 10 which is equal to the value of 100 by 200. You will get some more rational number which has the same values. So that kind of collections of the rational number is known as equivalent numbers. So 1 by 2, 5 by 10, 100 by 200 or 3 by 6, all these are equivalent numbers. Next we'll come here, the second problem. 0.2 I can write as 2 by 10. As we see here, 5 by 10 as I can write it as 0.5. So 2 by 10 which is equal to 0.2. 0.5 is 5 by 10 and 0.3 as 3 by 10. 0.75 as 75 by 100 because we have two digits after the decimal point, right? All these numbers you can observe which is in between 0 and 1, right? 0.5 here, 0.2 here, 0.3 here and 0.75 nearly here, right? All these numbers between 0 and 1. If I take rational number 2 by 10 and here 75 by 100, now we can see two rational numbers between this 2 by 10 and 7 by 100. But I can write some other number 0.4 or 4 by 10 which is also in between 2 by 10 and 7 by 10, and I can write any infinitely many rational number between 2 by 10 and 7 by 10. 0.25 also belongs to in between 2 by 10 and 7 by 10, that is 25 by 100 also belongs to in between 2 by 10 and 7 by 10. So there are infinitely many rational number between any two rational number. Please note down, there are infinitely many rational number between any two rational number. There are infinitely many rational number between any two rational number. Find 5 rational number between 1 and 2. Already said there are infinitely many rational number between any two rational numbers. So I'm taking 1 and 2. Between 1 and 2 I have to get 5 rational numbers. Okay, between 1 and 2 to get 5 rational number. If I get the middlemost number between 1 and 2, which is also a rational number and which is lie between 1 and 2, right? So that number become one of the rational number between 1 and 2. How to get the middlemost number? If there exist two numbers r and s, then the middlemost number become r plus s divided by 2. Adding these two numbers and dividing it by 2, you will get the middlemost number. So here r is equal to 1, one number is 1, the second number is 2. To get the middle number, I have to add 1 and 2 and divide it by the number 2. That is 1 plus 2 is 3 divided by 2. Therefore 3 by 2 is one rational number between 1 and 2. Now observe here carefully. If I get middlemost of 1 and 3 by 2, it will come around here, right? Which is also rational number between 1 and 2. Correct. if I get a middlemost number between 3 by 2 and 2, it will around come here. So which is also a rational number between 1 and 2. So I am taking R as 1 and S as 3 by 2 to get this number. Okay, how to get this? 1 plus 3 by 2 whole divided by 2 by taking LCM or by making the denominator as 2. I have to multiply the numerator and denominator of 1 by 2. It give 2 by 2 plus 3 by 2 whole divided by 2, that is 5 divided by 2 whole divided by 2, that is 5 divided by 2 into 2 is 4. Therefore this number is 5 by 4. It's already we studied, but I am just recalling the concept. And the middlemost number between 3 by 2 and 2, to get 3 by 2 plus 2 by 1, I can write 2 as 2 by 1 whole divided by 2. To get the denominator 2 here, I have to multiply numerator by and denominator by the number 2. Right? 3 by 2 plus 4 by 2 whole divided by 2. 2 2s are 4, 1 2s are 2, which is equal to, here the denominator is same, I can directly add 3 and 4, which is equal to 7 by 2, 7 whole divided by 2, that is 7 divided by 4. Therefore the middlemost number between 3 by 2 and 2 is 7 by 4. Now you can see 5 by 4, 3 by 2 and 7 by 4 are 3 rational numbers between 1 and 2. Right? We require 5 rational number. I will follow the same procedure for getting number between 5 by 4 and 3 by 2 and 3 by 2 and 7 by 4, where R is equal to 5 by 4 and S is equal to 3 by 2. 5 by 4 plus 3 by 2 whole divided by 2. Here we have to make the denominator 4. So I am multiplying the numerator and denominator of 3 by 2 by 2. So it is 5 by 4 plus 6 by 4 whole divided by 2, that is 11. Here it is 4 into 2, 8. So it is 11 by 8. Same way for 7 by 4 and 2, 7 by 4 plus 2 by 1 whole divided 7 by 2, 7 by 4 and 2. Okay. 2 divided by whole divided by 2. To get the denominator 4, I am multiplying and dividing by the number 4 to 2. 7 by 4 plus 8 by 4 whole divided by 2, that's equal to 15 by 4 to the 8. So this number is 15 by 8. Therefore, we are getting the 5 rational number: 5 by 4, 11 by 8, 3 by 2, 7 by 4, 15 by 8 between 1 and 2. Between 1 and 2. This is one method to get the 5 rational number between 1 and 2. Okay. There is one more procedure to get the rational number. Here we require 5 rational number, so I have to rearrange 1 and 2 as the denominator is 1 more than 5. Okay, that is 1 can be written as 1 by 1. I have to make the denominator as 6. Therefore, I should multiply the numerator and denominator by 6. It will give 6 by 6. Therefore, 1 is equal to 6 by 6. Here also 2 is nothing but 2 by 1. I have to make the denominator 6. So I have to multiply numerator and denominator by the number 6. It will give the numerator as 12, denominator as 6. Therefore, 2 can be written as 12 by 6 as the base, or as denominator value as 6. You can observe here, between 6 and 6 and 12 and 6, there are 7 rational number, that is 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. Oh, sorry, there are 5 rational number between 6 by 6 and 12 by 6. Right. So it is one of the easiest way to get the 5 rational number between 1 and 2. Now I am considering 3 rational number and decimal expression. The first one is 7 by 8. Here 7, if I divide 7 by 8 like the normal division, I will get the remainder as 0. If the remainder is 0, then in the quotient it will end with a finite number after the decimal, right? Here the remainder is 0, the quotient will be 0.875. This is the proper, or this is the decimal expression for 7 by 8. In some other example like 10 by 3 and 1 by 7, the remainder would become 0. Here the remainder is 1 every time, and here the remainder is 3, 2, 6, 4, like 3, 2, 6, 4, 5, 1, 3, 2, 6, 4, 5, 1, like that. The remainder won't become 0. In such cases, we will get a repeated number in the quotient. Here, the remainder is 1. Every time remainder is 1. Therefore, the remainder, the number in the quotient is repeating. You can observe here. Here 3 is repeating every iteration. 3 is repeating every iteration. Therefore, 10 by 3 I can write it as 3.333333 and so on. Instead of 0.333333, I will use 3.3 bar. This bar indicates 3 is repeating indefinitely. This is a number which is repeating. This is one example. Our number is repeating indefinitely. Here you can see the remainder repeats after 6 digits. 3, 2, 6, 4, 5, 1. After that again 3, 2, 6 you will get. Okay. In such cases, after 6 digits in the quotient, the block of number repeating. Here I can write 7 by 6 as 0.142857, again 142857, again 142857 you will get in the quotient. I am using the same concept of bar here. So I can write 1 by 7 as 0.142857 whole bar. This is the decimal expression for the rational number 10 by 3, 7 by 8 and 1 by 7. And the decimal expression for 10 by 3 is 3.3 bar. The decimal expression for 7 by 8 is equal to 0.875, and the decimal expression for 1 by 7 as 0.142857 whole bar. Okay. Now I can convert any decimal expression into the rational number. .875. First I will consider 0.875, which I can written as 87 divided by 100, right? Sorry, 0.875, right? 875 divided by 1000, since there are 3 number after the decimal, have to divide it by 1000. Now you can see, if we divide 1000 and 825 by the number 125, 7s are 875, 125 8s are 1000. It will give the rational number as 7 by 8, which is simple. Come to this point. Here 3.333333. So there are infinitely digits after this decimal point. So we can't consider, or we can't take the number as a denominator like 10, 100 and so on, like that. So I'll take one this 3.3333 so on as x. Okay, and I will multiply 10 to the x, that is 10 to 3.3333 and so on. What if you multiply 2 to the 10? It will give 20, right? One digit or 0.2 into 10, it will give us 2, right? One decimal point is shifting to the right side. Same way here also 10x become, here one decimal point is shift to the right side, then it become 33.3333 and so on, right? And I can write 10x as, if I split 33.3333 as 30 plus 3.333333, then you will get the right hand side also x, 3.333333, nothing but the x. I can replace that value as x. So 10x become 30 plus x, or if I shift x to the left hand side, it becomes 10x minus 9 is equal to, 10x minus x is equal to 30. 10x minus x is 9x, which is equal to 30, or x is equal to 30 divided by 9. Or here we got, what is x? X is nothing but 3.3333, which is equal to 30 divided by 9. We got the rational number for 3.3333, and we can reduce this rational number by dividing the number 3. 3 tens are, 3 threes are 2. So the final rational number is 10 divided by 3. So we can convert any rational number to the decimal expression, or any decimal expression to the rational number using this procedure. We got the decimal expression for 7 by 8, 10 by 3 and 1 by 7. There are two cases. One thing, the remainder becomes 0, and the second case is remainder is not equal to 0. Here in this case the remainder becomes 0, so the quotient also have the finite number of element. Here the remainder is not equal to 0 in these two cases, then the quotient is not have the finite number after the decimal. There are infinitely many numbers after the decimal, right? So if you have the finite number after the decimal, such kind of decimal expression is known as terminating decimal expression. Terminating decimal expression. If we are getting the quotient where the infinite number after the decimal expression, after the decimal point in the decimal expression, then such kind of decimal expression is non-terminating decimal expression. Non-terminating decimal expression. But here the number is 3 is repeating infinitely, so which is recursive. Recursive. These two are non-terminating, which won't end, but the number 3 is repeating, so it is recursive. Here the block of number 1, 4, 2, 8, 5, 7 repeating indefinitely, so this is also non-terminating but recursive expression of decimal expression. Okay, these two are terminating or non-terminating, so I can define the rational number using these two, that a number which is either terminating or non-terminating recursive, then such kind of number is a rational number. So I have one more number, root 2 or root 3 or pi. The value of pi is 3.1428 and so on. Value of root 2 is 1.41 and so on. Here in the decimal expression, after the decimal point there are infinitely many digits and no repetition in the blocks of digits. So these numbers are non-terminating and non-recursive. Non-terminating and non-recursive. Such kind of number is not a rational number. Then such kind of collection of numbers is known as irrational numbers. So we'll have one more collection, namely irrational number. I can define this as a number which cannot expressed in the form of P by Q. A number which cannot expressed in the form of P by Q, such kind of number is known as irrational number. In the next video we will see about irrational number and the real numbers and the representation of a real number on the number line.